Welcome to the third lecture on data mining. Today we will talk about some of the pre-processing techniques that are necessary before we actually perform the data mining. Before doing the pre-processing, we should look at what are the quality and other issues that are to be considered before performing the pre-processing. So, there are three questions that we will answer. What kind of quality problems can happen? How do we know that there are problems and how to solve them? There can be several type of quality problems. For example, you might have noise and outliers, which is the most common problem. We can have missing values and we can have duplications in the data. A data item captured multiple number of times. So, the most common example is a noise. So, you can see that noise usually is some kind of distortion on the actual data. For example, this is a speech signal and if we have a noise to it, it becomes there is a distortion, maybe due to the telephone or some snow or something, there may be distortion. So, this is the first problem that you will encounter in the data. Often the data will have some unnecessary component which is noise, which we should remove before processing. One thing related to noise is that of outliers. Okay. So, these problems, so you can notice that for example, if your data visually looks like these clusters and these red ones are kind of the points which you can sort of perceive not belonging to the other. So, a outlier is something which we know that definitely not come from the same mechanism that the other data has come. Maybe this outlier has happened due to some sensor error, due to some error in notifying some data, maybe somebody has wrongly entered a data. For example, if people are noting down height of a person 7 point or 6 point something, maybe missed the decimal point and it has become 611 or which is way different from the other height values. So, again if we have outliers in the data, this may mislead our mining algorithm. So, we need to remove outliers too. Another common problem is that of missing values. Either people have some information is not collected, maybe it is not available, or intentionally some values are not given. For example, people have declined to give their age and weight. Similarly, annual income for a children below 18 years old is not applicable. So, we have several ways by which we can handle these missing values. We can either eliminate them, the straightforward way is to ignore them. We can estimate them and replace them with the estimated values weighted by some appropriate probability factors. It may also happen that there may be multiple data items representing the same thing. So, for example, this is common when we merge data from heterogeneous sources. So, the same person's record, for example, income tax data, PAN card data. So, the same person information has come multiple number of times, they are repeated. So, in the process of data cleaning, we should be very careful to not to include such duplicates, so that we are not misled by the outcome. Note that the data mining algorithm gives result it extracts only what is there in the data. So, if your data itself has this kind of errors and duplicates, of course, the output of mining algorithm will be erroneous. So, the preprocessing is indeed an very important step. So, this is the third problem that preprocessing algorithm needs to solve. Okay. So, what are the different kind of preprocessing algorithm? By the way, preprocessing is required not just for improving the data quality, but also sometimes for two other purpose. One purpose is, after this preprocessing, your data may be more valuable, it may be more informative, it may give more information about the event after all this processing. Second is, it may reduce your computational load, it may throw away unnecessary things and have only the necessary information, so that your computational load is reduced. So, here are the preprocessing steps that are usually followed: aggregation, sampling. So, aggregation means sometimes you consider a bunch of data together, not a single data, a bunch of data together, and the cumulative information of all this data is what is used. The second is sampling. Here only few representative data is kept, rest is thrown away. The idea is that only the sample is enough, only the sample is enough for the processing. So, the next what we have is something called, of which the third, the fourth and the fifth falls is dimensionality reduction. The most common example I would give, for example, if you go to a doctor with lots of symptoms and lots of measurement, the doctor would not look at all of them, the doctor will select few of them. So, he will try to figure out which are the important ones and just pick up few of them. So, this process of picking up only the information that is important is the process of dimensionality reduction. You pick up only the attributes that are important. There are two types of dimensionality reduction, either is a subset selection, another is a feature extraction or creation. The other preprocessing operation is, sometimes you may have to discretize the value, and the direct continuous value may not be useful. For example, age range, okay, these kind of things you may have to discretize or binarize. Okay. Similarly, you may also have to do attribute transformation, you may have to transform the attributes. For example, I have to scale it by some factor, instead of in 10 to the power 20, I may have to scale to log scale or something. Okay. So, that is attribute transformation. I tell you some more details of these individual steps that are important in preprocessing. Aggregation is combining attributes or objects into a single entity. For example, maybe the sales of Coca-Cola or some soft drinks in an entire district, instead of storing the values in the individual towns in the district, I may add them together and have the entire district sales before I do the mining. Okay. This reduces the data, this changes the scale, and you have a more kind of average or stable data which has less noise, less variability, less noise, more stable, more robust. mm, a sort of alternate to this technique is do not add up, you just pick some, throw the rest, do not add up, just sample it. So, if we take the sales of a soft drinks in a district, instead of adding up over all the towns, just take few representative towns and take their value. Okay. So, that you would call as a sampling. So, sampling, as you know, is a very well known process in statistics. It is very commonly used in statistics, in any sample survey or anything. One important thing to note down in this regard is what your sample size should be. Okay. You have to decide the appropriate sample size so that you get a fair representative of the data distribution. That should be the goal. So, again that is a challenging problem. We will see as we study the algorithms how to decide on this. Representative sample, the idea is it should work as well as the entire data. Okay. So, some of the common sampling types are simple random, without replacement, stratified. That means, you take equal number of samples from each class, each group. Okay. Others one you can clearly understand that sampling without replacement and without. Each of these techniques have their own advantages and disadvantages. There are many other type of sampling also, bucket sampling which is suitable for a large volume of data, and many other techniques are there, but depending on the problem some sampling algorithm is suitable, which again when we discuss the specific algorithms we will decide which is the best algorithm. Next we have the dimensionality reduction. The problem is higher the dimension of the data, the more number of attributes, the difficulty it is to model, both in terms of time and in the complexity of the models. So, it is wise to reduce the dimensionality as much as possible. So, reduce the memory and time requirement, easier visualization, eliminating irrelevant attributes. There are two types of techniques, supervised and non-supervised. Unsupervised, which tells you that this supervised somebody tells that this is good, unsupervised nobody tells. And one of the common technique here is the famous principal component analysis, which is the most widely adopted technique. So, what is done in principal component analysis is can be very easily visualized using this data. So, each of these blue dots are, say for example, data points with two measurements x1 and x2. Suppose I ask you that I will not allow you two measurements, two coordinates x1 and x2, give me a single coordinate which may be tilted, not same as x1 and x2, along which if I project my data, it would retain the maximum information of the data. So, you can see that if your data looks like this and E is a direction, E is a direction, E is a tilted direction somewhere in between x1 and x2. On this line E, if I project my blue points, I sort of project them onto this single dimension instead of 2 x1 and x2, the data sort of retains the characteristics of the original data. It retains the character, it looks as if the same, the distribution, the spread, all these are more or less reserved. So, this direction E is called the principal component of this data, is called the principal component of this data. How to find that? So, what we do is that find the covariance matrix of the data. What is the covariance matrix? We find out the variation of the data along each x 1 and x 2 and x 1 with respect to x 2, x 2 with respect to x 1. Okay. So, how much the values of x 2 of different point deviates from their mean value. Similarly, x 1 deviates from their mean value. Okay. Similarly, x 2 deviates from mean of x 1 and so on. So, you will get a 2 by 2 matrix in this case. It turns out that principal component direction E is nothing but the direction of the principal eigenvector of this covariance matrix, the direction where the principal eigenvector points to. Principal eigenvector means the eigenvector corresponding to the largest eigenvalue. So, in this PCA or principal component analysis, what we do is that we select altogether a new direction E. But suppose I ask you, in between x 1 and x 2, which one should I choose so that I get the best representation? I cannot choose both, I have to choose only one. So, this problem is known as the feature subset selection problem. It need not be 1, it may be say 2 out of 5. Okay. So, this problem is known as the feature selection problem. This is also an important pre-processing step. This is usually performed before actual processing is carried on. These are the approaches. So, what you basically do is that try out all combination of features, find out which one is best, select that. How do I determine which is best? By seeing some criteria, feature evaluation criteria. Okay. So, there are many ways like embedded approach, filter approach, wrapper approach, okay, which would find out the best subset. Similarly, there are methods in which you combine these attributes or features into a new space called a feature creation, into a new domain specific space. For example, in physics we do like say force into time is work. You combine some values to create more meaningful information. Okay. So, the next pre-processing task is that of discretization. Okay. What it means? It means that suppose I have continuous data, say these different colored points. Instead of this continuous value, can I represent them by some intervals or discrete bins, say age of a person. You might have seen in customer surveys they give 10 to 20, 20 to 30 and so on. So, the question is what is this right partition? So, equal frequency or equal interval or some clustering which is k-means, we will come to it later. What is the right technique? So, there are different discretization techniques that one might follow. Okay. So, this I also talked about, either normalization, standardization, applying some function to do the attribute transformation. Again, there are no general techniques of doing this. Many of these are domain dependent. You have to look at the data. It is like an art. You as you gain experience into data mining, you know what is the transformation you should do, what kind of normalization you should do. Okay. So, the purpose is if you do this, you have more useful information. Okay, so after this preprocessing, that is another quick thing before we need before doing any data mining algorithm, is a notion of similarity or dissimilarity between data items, some numerical measure, how different or similar are two data items. So, for the case of continuous or interval or this kind of attributes, continuous values, you can use the distance, some Euclidean or other distance as the dissimilarity, but for other type of attributes that we studied, you should have alternate definitions. So, here are some common definitions, say nominal, same or binary, ordinal, some mapping value, interval, some difference. Okay. So, these are some functional forms which are commonly used. You can have your own form too. And if it is continuous, we can define distance for similarity. The thing is that all these similarity values and all these things, we will need them later when we develop our algorithm. So, in today's lecture, what I am doing, I am giving you a broad idea, not details of any method. I am giving a broad idea about the steps and measures you should give. All these are preparation before you actually do your data mining. So, here is the common distance function, the Euclidean distance. It is difference between every dimension k, p and q values, square them up, add them up, take the square root. You can have other distances. So, this is same as the Euclidean, but with a weightage factor. Some attributes sigma, some attributes are given more weightage than the others. The attributes which are spread apart are given more weightage. Cosine similarity, as if these attributes are vectors, cosine similarity is nothing but the cos of the angle between them, the dot product. Okay. So, this you can use for anything. A similar thing is something called a Jaccard coefficient. If these values are binary, you can treat them as sets, and you can say number of matches divided by number of total number of attributes, number of attributes which are common. This can be shown that this is equivalent to a cosine similarity if we consider binary factors. Basically, number of attributes where they are 1 in both the vectors. Correlation. So, it is the mean subtracted divided by the standard deviation and the product, dot product of these two. Okay. That would give you the correlation. Okay. So, this is the meaning of correlation. If they are correlated, that means they fall on a line, okay, and so on. Negative correlation means negative line. So, this is all. These are the preprocessing steps that you would like to undergo before we actually do the data mining. So, as a summary, what you should learn from this lecture is that what are the quality measures, what are the sources of poor quality in data like noise, outlier and such things. What are the preprocessing steps that helps you improve data quality, reduce time, produce better relevant model. These steps are sampling, aggregation, dimensionality reduction, feature selection, discretization, noise removal. And then finally, you need some kind of similarity measure between the data, which tells you that how similar two data items are. This is also a kind of preprocessing step. You need to a priori fix this before you do the algorithm. After all these steps are ready, you are kind of ready for the mining algorithms to run. there are different kinds of mining algorithm that I had already mentioned in the introduction, like association rules, classification, clustering. So, what we will do in the next class, we will assume that all this preprocessing is done and study these algorithms. We will start with the association rule method in the next class, okay, and find out how you can apply them, what is the algorithm, what is the output. So, this is for the preprocessing and distance measure this lecture. This closes the initial part of your course, the introduction and the preprocessing. Next we will move on to algorithm. Thank you.